Hello, everyone. I'm Mark Peacock, Vice President, Chief Marketing and Communications Officer at Lynxspring. Joining me today are Robert Hirsch, Chief Business Operations Officer, and Jake Neiman, Executive Director of R&D. Today, we're going to be talking about two new additions to our product and solution offerings, the JENEsys Edge 634 and the Onyxx Wall Module. The JENEsys Edge 634 represents the 8th Niagara-embedded Niagara native controller in our JENEsys Edge product portfolio. It's a leap forward in embedded Niagara controllers driven by our Lynxspring smart module and an all-new multi-core processor. It is engineered to elevate connectivity, control, integration, and data, and combines high performance, speed, reliability, and E2E and AI readiness in a compact module platform. In addition to the JENEsys Edge 634, we will share with you the new Onyxx Wall Module. The Onyxx Wall Module delivers precise temperature, humidity, and additional environmental sensing capabilities. Featuring a high-resolution, full touchscreen interface, it provides real-time feedback and intuitive control. Now, Robert, Jake, take it away.
Mark, this is Bob Hirsch. I'll kick us off. You heard from Mark, and with me is Jake Neiman. So today we're going to talk about I'm going to speak to more of the 634 hardware. So here we go. The JENEsys Edge 634 is a new controller from Lynxspring, and it is in part with our family of other JENEsys Edge controllers, which include 534s, 434s, 514s, and 414s, and our VAV application-specific controller, all interoperable with any Niagara solution, including JENEs and JENEsys and supervisors, and also interoperable with our Lynxspring Edge to Enterprise Cloud services. The Edge 634 includes some of these technical specifications of internally. You can see the boards that we have here. We have a lower board, a smart module, a Lynxspring smart module, an upper board, a status indicator board, and so forth. And we will go through those individually and give you some more detail as we go. But if you took all the plastics off, this is what it looks like inside the 634. All right, so we'll look at the lower board first. Lower board, as always, includes power supplies and universal inputs, and includes a number of hardened applications that we've added to the controller to protect the device from dirty power, insufficient power, miswiring, those types of things. The lower board protects itself. It has plenty of PTCs and everything else that we'll probably get into a little bit more detail. But anyhow, the lower board, what is critical about the lower board, if you opened up a 534 and looked at 634, the power supply is integrated within the board itself. It's not soldered to the board. We used to have a power module that was independent of the lower board, but now they're integrated together. The Lynxspring Smart Module 2, LSM2, that's our second LSM. Our first LSM, it still resides within the 500 and 400 and VAV versions of our Edges, but the Edge 634 now includes our LSM2. And it's a little deviation from what we had in the past. It's now a system on module board with increased CPU, increased memory performances. It has been enhanced, and And you'll find with your own experiences, the LSM2 is really skyrockets the performance of this Edge 634 versus your other previous experiences with the 500, 400 series. Upper board. Upper board is is really our output board. It includes our digital relays and analog outputs, things such as that. It also includes our RS-485 or serial communication ports. It also hosts, excuse me, also hosts some different optional carrier boards, such as our wireless modules that we have in place. If you ordered a wireless option like our Monet solution, fits on that. Our cellular options, they fit on that upper board. You can see to the right of the arrow, there's some empty places to add those boards. Excuse me. Status indicator board, we used to call the LED board. It includes a number of different LEDs to indicate digital outputs, various types of communications, a heartbeat, power is on, and status. The new board that we have now includes RGB LED indicators, so you can begin to imagine programming these LEDs to different colors or have different meanings for the optional lights that you have, that the RGBs will eventually give to you. The Onyxx Wall Module is integrated into 634 as a permanent feature. So you see an RJ11 connector there, and it accepts a direct connect to our Onyxx Wall Module, which we'll talk about later. Edge 634 also hosts a different temperature range or operating temperature range, and we'll get into that in next slides here. Okay, I'm gonna go through this pretty quickly, but the Edge 634 lower board is a re-engineered lower board from where we were in the past. It's pretty much re-engineered in the sense that it's been enhanced. It's been we've taken what we've learned over the last 5-6 years of the other edges and now incorporated into this lower, including a tremendous amount of protection. The power supply, like I said, has been integrated into the board. The half wave rectification is now versus the full wave rectification, which is something that our customers were asking for. And the board is now not just a 2-layer, it's now a 4-layer board, which gives us a number of different advantages as well, including thermal management from the many heat generating devices or components that are on that board. We've also included a numerous quantity of PTCs or thermal fuses that will help protect the product from, like I said earlier, bad power, insufficient power, dirty power, whatever you want to call it, miswirings, and so on and so forth. Additional I/O protection included for the analog inputs includes MOVs or metal oxide varistors, PCP spark gaps. All these protections have been added to the board, and so that it can survive in environments that sometimes you're going in to do a retrofit and you don't know what's on the other end of that wire. However, we place the wire on the device because we're doing a replacement, possibly, and if there's something that is not in good shape there, the product will protect itself, and then you can fix the field issues that might be present. The LSM2, like I said, is a system on module. It hosts the IMX 93 or 9.3 CPU. You can see the specifications here. It's a dual processor, tool core processor. It has, excuse me, increased memory of 2 gigs versus I think we had a half a gig in the past, 32 gigs of eMCC, and additional storage. The Ethernet, The Ethernet ports have been increased to 2 gigabit type of speed Ethernet ports. So it hosts the transference of communications and the latency has been increased and latency has been eliminated, basically. Real-time clock. There is a real-time clock, but however, in the past, we had a lithium battery that would host a real-time clock. That is gone. We have what's called a super cap that replaces that battery. So now we've engineered the battery out of this controller. The carrier board, which is pretty straightforward, it hosts the LSM2 CPU and SOM. It's required, and then it fits directly on the same footprint that the lower board has in the past. So you can see in the future any other design changes, it will be straightforward, compatible with the lower board architecture. The indicator board, we said in the earlier that it does host the RJ12 jack, which is very important to understand that. That is a standard on the 634 that accepts and can support up to 4 Onyxx Wall modules directly. It's standard as opposed to optional. The 534s and other Edge devices also can support an RJ12 jack, but the LED has to be, or the indicator board has to be switched out to one that has that RJ12 jack. So that's not a problem, but the 634, it's standard across the portfolio of 634 options. And by the way, the RJ12 jack does support 4 wires. I believe it's 4 wires that goes to the Onyxx Wall Module. You got power, you got communications, and it just connects directly to the OWM on the back of it. And it's the easiest thing you ever seen. Okay, we talked about operating temperatures earlier. The operating temperature has changed, and it has the range that it represents now has gotten wider. So it can be installed or considered or specified in much more critical environments that require these conditions. Now, standard use case is a -20 to 85 C. That it equates to -4 to 185 degrees Fahrenheit. I believe our last one might have been 0 to 65 or something like that was the operating range that we had specified, but now we're specifying -20 to 85. And then there's an industrial actual option that can be solicited to us. So if you need an edge to operate in even wider ranges, you can get an industrial one that supports a -40 degrees Celsius versus the -20. So that's pretty exciting as well. Okay, now enough of the hardware. We're going to turn it over to Jake Neiman, and he's going to talk about software.
Let's dive right into it. So just a few features on this. We wanted to add the features that make sense and capabilities that we have. AI assisted diagnostics. The IMX 93 sports a neural processing unit, so we leverage that to kind of monitor internal temperatures and voltages and try to see things. If something starts to deviate, we kind of and start to learn its patterns and see if there's something that needs to happen to address that. So that's something that's new to this. Our digital Boolean input point is another thing. This is a rapid response type of point. So for door sensors and things like that, when the sensor changes state, you'll see it update in about less than a second in Niagara, which is significantly faster than it is on the 534 and 514. Rapid spanning tree protocol. We elected to support that, so that you quicker reconnect if it's set up in a spanning tree loop. Since we have 2 gig of RAM, we elected to increase the amount of memory we've given the JVM. 888 megabytes is what we chose to do. It's about 4 times what we did on the 534. E2E connection ready. Basically, what that means is all of the controllers come licensed and ready for E2E support. All that's required is installing the service and setting up your connection with E2E, and you're sending data to E2E. As I mentioned just a little bit ago, the neural processing unit, which is specifically designed to handle AI type of instructions, it can process those significantly faster, and there's no load on the main CPU in processing those. As Bob mentioned, the Onyxx Wall Module support is there. We have in our benchmarking as well as customer feedback, we've been told that the web user interface access is at least 4 times faster, if not, depending upon what your interface is. You can expect a 4x improvement, but might even be faster than that. Our Helix operating system, it is a derivative of Linux, but it's custom built specific for our platform. There aren't any extra libraries. It's very much what you need is all that's there. This helps with several things. One, download speeds, things like that. Upload, we can keep the size of the operating system small to where updates are easier, faster boot time, a significantly faster boot time, really, which is important if you're updating a lot of these or trying to do something over a slow network or things like that. As I mentioned, rapid spanning tree. Yeah, that's the main thing there. So onboard I/O improvements, the new Boolean digital input, as I mentioned, but we also changed the I/O polling to try to increase the update frequency of the other point types, not just the Boolean input point. And it also reduces CPU impact so that there's very little impact on the CPU for the onboard I/O polling. Kind of break down our components for machine learning. These are the parts of the IMX93 and how it's really built around machine learning or AI. You got your main AI cores that handle kind of bringing all the data together, getting ready for processing of what what you want your AI to do. Coordination, which is the other additional cores, not the MPU, but getting ready for the MPU. It handles and kind of coordinates how the instructions are going. So it's kind of the conductor, if you will. And it tells the MPU exactly what to do, and then it does what it does extremely fast. Light RT, which is formerly TensorFlow, is what the framework we use for our onboard diagnostics. We found it was the most effective, and it was very well supported by the Ethos neural processing unit. Yeah. So this kind of gives you an idea of just basically a more generic version of what I've covered in detail there. This kind of shows what this is capable of doing from a machine learning standpoint. You take in data and then you feed it through the 4 pieces I just mentioned, and you get the output basically based on that processing and whatever learning the model had conducted prior to that. Here kind of gives a better breakdown of the JVM memory allocation. Our code cache is 128, heap space is 768, and metaspace is 256, which is significantly, like I mentioned, it's 4 times what we did previously. So we've seen this assists the UI updates and things like that. This makes it update much faster and just perform better all the way around. This kind of will give a benchmark of just a simple station. And when I say simple station, I mean something created with very little stuff on it, right? You go up new station and here's what you get. From with the daemon running, or to get the daemon running after power applied is about 30 seconds, which means if you put power on it and your workbench, you should be able to connect to it within 30 seconds. Now to get a station up and running, that's 80 seconds from that same event. So I apply power and within 80 seconds, that station will be up and running. And from if power is already applied, so the daemon is running and you just go to start the station, it takes about 45 seconds. And here's the output of that. So if you're running that simple station, as you can see, the CPU usage is minimal. I think our peak is about 20%, but that's for a split second when it probably did a garbage collection or something. So the average here is running about 5, maybe 6% CPU. Significantly better than a 534, because same station, you'd see it about 30 to 35%. So this is a loaded station, 7XM, still the same daemon start time. The difference here is when power is applied, it takes about 110 seconds versus the 80. But this is a loaded station, so you would expect it to take longer, but it's still significantly faster. This same station on a 534 would probably take, I wouldn't say double that, but at least an extra 45 seconds. For a station start time with the daemon running, it's about 58 seconds. And here's what the CPU and memory look like. And you can see the CPU uses a little bit more. Again, you see a spike. And again, that's probably a garbage collection or a poll or something like that. But the average is very reasonable considering what, how much that station is actually doing. So we expect this to be able to handle much larger stations than you could do on a 534 or 514. Current support for the 634 from a Niagara version is 410U11, 413U3, 414U2, and 415U1. Our licenses are about the same on the 534 with the exception of these two larger licenses, the 25 device and 1250 point, and the 100 device and the 5000 point. We have complete confidence that it can handle a station that would leverage those larger licenses and be able to perform exactly as you would expect.
All right. Hey, everybody, I'm back. Let's talk about the Onyxx Wall Module. I'm the hardware guy, I guess. So please bear with me. It's the Onyxx Wall Module. If you haven't seen it, there it is in the middle photo there. The other photos is the front and back supporting PCB that's internal to the device itself. But we're going to go over these listed topics here that are listed up on the left-hand side. Sorry, I'm having a throat issue, but I'm dealing with it. Anyhow, we'll get to that. CPU modules. It's kind of cool. ESP has really neat CPUs. We leverage the ESP32 module in this case. Has a very good operating speed. It's very responsive. And the memory, as you can see here, is available on the device itself. Sensors, multitude of sensors either are existing and or are planned or will be released soon. Temperature humidity is on the unit now. So when you order a Onyxx Wall Module, you're going to get an Onyxx Wall Module that includes a temperature sensor and a relative humidity sensor as well. You can see the specifications around those particular sensors themselves. You can see to the lower right, it's highlighted there, those sensors and their location. Pretty neat how they're isolated from the other part of the PCB to minimize any kind of influence from PCB heat up or other components heating it up. Ambient light sensor, that is senses when someone approaches the device or senses if it should be in bright or lessening brightness, I should say, when it's hanging in a space where it may be occupied, it may not be, lights may be on and lights may be off. And there's a sleep mode, I believe, that so it will wake up when someone when it sees motion. The CO2, that is an optional sensor that will be released in the end of beginning of next year. And what's pretty neat about the CO2 sensor is that its size. I grew up in a world where CO2 sensors were pretty good size, 50-cent piece size of sorts sometimes. But these CO2 sensors that are available today are much smaller, much more applicable to a product like this, and can be carried much easier going forward. Radar is planned to be a part of the device itself, and look for that coming soon. Oh, we went through all these. Sorry, I bypassed all this. So we're going to go through this really quick. So we got the ambient light, senses ambient light, so it knows whether its lights are on. CO2 is optional, will be coming out Q1. And the radar is optional as well. So that's coming out soon as well. Right now, in both cases, CO2 and radar, we have prototypes in the office that we're testing as we speak. There's some tweaking that needs to be done there. We want to make sure are calibrated as closely as possible and they leave the factory, and that if they need to be calibrated in the field, we have those capabilities as well. The LCD itself, that's where the display of what's being presented by the Edge controller, I should say. And you can see the size 2.5 or 2.4 inch display. The resolution is 240 by 320, and it's a full view display with backlighting and auto dimming. Okay, touchscreen and the front panel buttons. The touchscreen itself is capacitive touch, and the entire face of the sensor includes that. It can be touched. So the display itself is touch, but also below the display where those buttons are located, you can actually program the device to have another touch. You're not necessarily where you see the light arrows, the up and down, left and right. Yes, those are kind of target touch areas for different actions that you want to program into the device. But you could actually create an area for a secret touch or something that is for service. You know, the ideas are plentiful. You can come up with different ideas. Those are the arrows that I was talking about. And you have a special, nice, beautiful looking Lynxspring logo there with the swish. Power requirements. Well, the power comes from the Edge, so there's really nothing that you need to be concerned with from a power requirement during installation. You're going to get the power that it needs from the Edge when you plug it into that RJ11 device. It's on the indicator board. Each Edge can support up to 4 OWMs using this little hub that we have shown here. We have those for sale as well, or available to you if you want to put multitude of wall modules into one Edge. Okay, how do these wall modules communicate? Well, of course, they communicate using the Onyxx network. Similar to the Onyxx network that is responsible for I/O control and for communication between XMs. It's the same network that communicates with the Onyxx Wall Module. And just FYI, we have tested and we feel comfortable with maximum distance lengths of 300 feet. Okay. Additional features include audio and haptics. That is optional, but the haptics are more, I think, is the vibration. You might find it similar on your phone. Sometimes if it's set up, you can feel it vibrating, giving you some feedback. The tactile feedback is exactly what they refer to it as. Operating temperatures are well within range of most applications that you're going to find this in. What's interesting though, it doesn't. You could apply this into warehouses, maybe some areas that are not conditioned, and so on and so forth, for whatever reason that you might want to do that. All right, so here's a sample of the wiring. I'm not going to go into too great a detail, but there's 4 wires that are required, and they generally include the let me get my glasses on, the power and the communications, and that's it. One end plugs to the Onyxx Wall Module, the other one plugs in the other wall module or into the edge. The item here on the second cable indicates leveraging an existing installed maybe thermostat cabling or that might be there, so you can reuse it. We include these terminal block adapters at each end, and you would wire up in that fashion. All right, again, only 4 of the wires are necessary. Some mechanicals, there's some drawings. It's a nice sleek device. It doesn't protrude away from the wall a great deal. So there's less chance of people running into it or walking into it or getting hooked to it. It's a nice design. You can see where it's got corners on top and bottom, and then it's got rounded corners on the other sides. And the mountability you can see over at the other. So the back side mounts to the wall, and you'll see that there's a number of different options there to mounting the device. It tells you which way's up. You gotta pay attention to what the orientation, so the device can be mounted correctly where the sensors are located in the right spot. Okay. Materials, like anything we build, their UL flammability certification using the UL 94, and they come in black or white, and the fingerprint, the glass on the front is high impact as well as fingerprint resistant, so you don't have all the little smudges from your fingers when people are operating it. We also have these two. Well, it's a single accessory, 2 different colors, if you call them colors, black and white, for when either you want to just have a decorative wall plate, or maybe the trimmed out gang box that you're going to mount this to is bigger than the sensor itself. So you can easily add this wall adapter to it. I called this I forget what I called a hub before, but it's actually called a bus, a 4-way bus. That's what that looks like. Up to 4 field devices in the bottom 4, and then the top connector connects to the edge device. Here's that pigtail connector. Again, if you have an existing cable from maybe a retrofit, you can use this adapter to use those wires over again and just connect it at the ends where the wall module and the edge reside. These are RJ12 connectors or crimp connectors, pretty basic. We provide those as well as if you need to extend an existing communication cable, we have these couplers. And then if you need this, you can go to Amazon, buy this, as well as Lynxspring has available to you this pretty handy device that we use frequently here for making the cables when we need to. Okay, now I'm going to hand it over to Jake for software.
Right, so let's look at software. So just to cover some of the features, Bob obviously covered a lot of these, but I'll go over them real quick. So we got the OLED color LCD. If you guys are familiar with OLED, they're very bright, very vibrant. All of the buttons are RGB, so actually RGBW, so they can be set to any color, and there are settings in Niagara that you can adjust the color either from Niagara or directly on the user interface. We offer a retrofit kit for any devices that are currently in the field, or you can obviously order it with this included, black or white for the body color, the 4 module support, and there are 2 different device module support. I'll explain this a little bit more later. We got a T-stat and a VAV. That we'll get in more detail on those shortly. Some of the sensors, Bob kind of mentioned this as well. There's temperature, humidity, ambient light, so you know what's in there. There's an optional radar sensor for proximity, and then our CO2 is coming in Q1 of 2026. As Bob mentioned, this is in prototype right now. This is our driver for Niagara that runs. It just shows these are the settings that you can adjust from the Niagara interface, and then the VAV device module and the T-stat device module. Again, I'll cover those in greater detail here shortly. This kind of shows in that in Niagara, in that service, here is one of the wall modules, and here's where you get the values, and then you just link to these and do with them as you want. You know, you can link them and do with whatever application you have. This is how you access those specific values. On the actual user interface itself, on the wall module, here are some things you can update. Display brightness, auto brightness using the ambient light sensor, as Bob mentioned. The backlight colors, you can change the both the color and the brightness. Select between Fahrenheit and Celsius. The device name, display auto off time, and radar settings. These are all settings that are inside the wall module. This is those same settings, but from the Niagara perspective, to allow you to adjust this from the station if you don't want to adjust it from the wall module itself. So if you've got a station you like and you want all the wall modules to be the same, nice thing here is you can copy that station to multiple devices. If they all have wall modules, you're able to leverage that and not have to go to each wall module and set it up. This kind of shows you some of the screens that you see on the wall module itself. This is kind of the format. This is how you navigate. It's a list view with drop downs to, you know, if you've got something that's a kind of an option drop down, you can you click on it, it drops down and lets you select whichever option you want. The color, if you click on that, it's a color wheel, which lets you, well, there you go. I can show you that. You can just drag it and move it in a circle to the color you want, and then you can watch the buttons change, the backlight behind them change to whatever color you select. This is the T-stat module. So on the VAV module, the screen layout is a little bit different. So on the T-stat module, here the values look like this. So you got active cool and active heat. And basically what that's showing is if it's in occupied mode, you're going to see the occupied heat and cool set point. And if it's in unoccupied mode, you're going to see the unoccupied heat and cool set points. You have humidity, and then it shows what mode it's in. And you can kind of see behind it, that's the wall module stat device, and you can see the occupied and unoccupied heat and cool set points, fan control, system mode. The fan control is auto and off, just like your normal thermostat. Your system mode is cool, heat, emergency heat. So here's the main screen for the T-stat, and this kind of just shows those items more clearly. So you got a title bar at the top, which notifications, you got your heartbeat, you got your lightning bolt, which is basically a communication indicator, OWM, which is a name that you call out in the service, and then the time. On the right-hand side, you've got the buttons, the active, cool, active heat, humidity, and occupied mode. And then you have icon status indicators. If the fan is on, the fan will rotate. If the snowflake will turn blue, which shows cooling. And it will gray if it is off, and then the flame will turn red if it's in heating mode. This is the user interface. If you this lets you change each one of those set points as well as the system mode. You can have auto, heat, cool, emergency heat, that sort of thing. This is the kind of another view of the Niagara component. It's a little better view than before. Each one of these is adjustable, right? You can either set it on the stat or on the wall module itself, or you can set it through this Niagara interface. And it lets you link into these points, and you can do with them, whatever application you want. You can set this up to do that. Our goal with this T-Stat device module is to allow for an edge device in the wall module to supplant a normal thermostat. And there's a lot of applications where that makes sense. And one of the big things that we heard from customers is they like the idea of, if a wire gets cut to that wall module, you still have, the functionality still running. So if you could set it up to where if that wall module gets disconnected, you're able to go into a standby mode and not have to shut the whole system down. If you just have a thermostat, if that wire gets cut, you're done. So that's a big upsell for this, because it gives the ability to separate those two out, kind of diversify that a little bit. This shows a wire sheet of a sample 2 heat 2 cool station. Shows very simple. I mean, this can be as simple or as complicated as you feel you need it to be. You're getting those set points and the control from the wall module settings, but then you can, expand on that. You could have it, this could control an inverter system with an inverter heat pump and blower coil, and you could have it run variable output all day long using the same wall module, or it could be simple 2 heat 2 cool, or you don't even need heat. I mean, you can set it up any way you want to. It's that versatile. So the logic for the stat to function is based on the wire sheet or the programming that you put in there. This shows the VAV version of this. You can kind of see they're different. Here you got an occupied set point, an unoccupied set point, and you also see a damper position, which is the yellow box there with the damper inside of it. We elected to make them, since they do different things, we really needed to be able to show that as a different, functionality is very different. And because of that, while yes, you can use a typical T-Stat for control, there are specific functions that are much better, like the damper, for example. It's very much a VAV thing. So this enabled that. And it does show actual position. So if you're the balancer and you're on site and you want to see where the damper is, you can go to the wall module and not have to climb up in the ceiling to see where it's at. This shows the Niagara component. You can see it has less options, less values, because it's less complicated. It's very specific. Here are the things that it does, and here's where you get those values. And we have a VAV station that this can be leveraged with, and you just include it, and it'll auto configure and link up all these things for you. But if you have your own VAV and you want to use the wall module, or you have your own VAV station want to use the wall module, here's what the points look like, and this is what you link to. The retrofit kit's pretty straightforward. It's a wall module, RJ12 and screw terminal adapters, which Bob showed earlier, and the LED panel that you have to pop out the original one and then pop this one in with the RJ12 connector. And that's all we got.
Thanks, Robert. Thanks, Jake. Greatly appreciate you sharing some of our latest stuff. If you'd like additional information, it can be found on our resources site, as well as lynxspring.com, our corporate site. Also, feel free to reach out to your regional sales manager, as well as drop sales@Lynxspring email if you have additional questions or need some assistance. We thank you for joining, and until next time, so long.